Hope you all noted till equation 1. Let's continue. So is it a homogeneous or a non-homogeneous equation? Guys,
Non-homogeneous.
correct. This is a non-homogeneous. This is a non-homogeneous equation with constant coefficients. The function f of t is called forcing function. If the forcing function is 0, the response of the system is referred to as free response. Full stop. When the system is driven by a forcing function f of t, the response is referred as the forced response. Right? In the following section, we will restrict our discussion to the solution of free response, because continuously there will be no gust or the force of excitation won't be acting continuously. For us, the free response is very important, or we can say homogeneous equation. So, right, the solution of the differential equation with constant coefficients is found by letting x equals to a e power lambda t. So x dot, if I take the derivative dx by dt, I get a lambda e power lambda t. And if I find double derivative of x, I'll be getting a lambda square e power lambda t. Substitute this in the homogeneous equation with f of t equals to 0. Right? From equation 1 with f of t equal to 0. Substitute in place of x dot a lambda square e power lambda t plus c by m a lambda e power lambda t plus k by m into x is a e power lambda t equals to 0. When you cancel out the like terms in it, throughout you have a, you cancel out that e power lambda t, e power lambda t, e power lambda t. It implies lambda square plus c by m lambda plus k by m equals to 0. bracket this equation, call it as equation number 2. Hope you all did that.
Yes, sir.
Yes.
which is called the characteristic equation, full stop. The roots of the characteristic equation are called the characteristic roots or eigenvalues of the system right. The roots of equation 2, that is the characteristic equation, are lambda 1 comma 2 is equals to minus c by m plus or minus under root of, that is b square, that is c by m whole square, minus 4ac. A is 1 and c is k by m whole divided by 2a. A is 1. So you will be getting lambda 1 comma 2 equals to minus c by 2m plus or minus under root of c by 2m whole square minus k by m. Bracket this equation. Hope you all got this root. Everybody?
Yes, sir.
Okay. Call it as equation number 3. The solution of the differential equation can be written as x of t equals to c1 into e power lambda 1 t plus c2 into e power lambda 2 t. Call it as equation number 4. The type of motion that occurs if the system is displaced from its equilibrium position and released depends on the value of lambda, which is a function of mass, damping coefficient, and the stiffness constant. We shall consider if possible case. we shall consider three possible cases of lambda. Okay, write case 1. Case 1. C by, so now everything is dependent on these things. What is going to happen on the term inside the root? If the value of C by 2m is greater than under root of k by m, it implies C by 2m whole square greater than k by m. If it is the case, what will be the roots, guys? What type of roots you will be getting?
Real and distinct.
Real distinct.
Real and distinct. What else can you say about the root? Positive or negative? Real can be positive, negative, zero, right? Positive or negative?
Negative.
Negative. Negative.
Correct. Right. The roots of the characteristic, equation are negative and real. Negative and real, comma, which means the motion will decay. The motion will decay exponentially with time. The motion will decay exponentially with time. So you write x equals to c1 e power lambda 1 t plus c2 e power lambda 2 t. Okay. So here both the powers lambda 1 and lambda 2. These two, both these, if they are negative, what will happen to the system? They will decay, that too in an exponential manner. Okay. So as you write, as lambda 1 comma lambda 1 and lambda 2 are negative, in bracket you write real, comma, as t tends to infinity, x will tend to 0. Hope it is clear. Agree?
Yes.
Both the lambda 1 and lambda 2 are negative. So as the time increases, the amplitude will decrease. So here it is not going to execute any type of oscillation. It's a motion. Anyways, you mark this as x0. So when the time t tends to infinity, this amplitude will come to the 0. There is no oscillation and it is decaying. It's called overdamped system. It's called overdamped system. Right? Write the equation of this motion x equals to c1 e power. First take the positive power, that is overall it is negative only, but take the plus term in the root and write it as c by 2m whole square minus k by m into t plus C2 into e power minus c by 2m minus under root of c by 2m whole square minus k by m into t. Okay, bracket it. No need of giving any new number to it, just leave it. Okay, hope you all reached till here.
Yes, sir.
Oh, right, case 2. In case 2, you take c by 2m less than under root of k by m. That is, c by 2m whole square is less than k by m. If that is the case, what will be the type of roots, guys?
Imaginary, sir.
Correct. They will be complex. So you write lambda 1 comma 2 equals to first minus c by 2m plus or minus under root of, if you take common minus 1, you will be able to write k by m minus c by 2m whole square. Do you agree? Agree? We can write like this, right?
Yes, sir.
So lambda 1 comma 2 can be written as minus c by 2m. I did only one minus common I took in the roots, plus or minus root of minus 1 is I, under root of c by 2m, k by m minus c by 2m whole square. You can write in bracket since I equals to root of minus 1. Okay, bracket this, call it as equation 5. Okay, call this as equation number 5. Right. The solution of the differential equation is x equals to c1 e power minus c by 2m plus I under root of k by m minus c by 2m whole square into t plus c2 into e power minus c by 2m minus I under root of k by m minus c by 2m whole square into t. Okay, from this if I take common e power minus c by 2m into t, I'll be able to write c1 into e power I omega into t plus c2 into e power minus I omega into t, where what is omega now? Under root of k by m minus c by 2m whole square. Hope you all got this. Everybody?
Yes, sir.
Yes, sir.
Okay. Now you write x equals to e power minus c by 2m into t into c1 into e power I omega t. By Euler's formula you can write it as cos of omega t plus I sin omega t plus c2 into cos of omega t minus I sin of omega t. Okay, from this you take the cos and sin terms together. So you can write C1 plus C2 into cos of omega t plus I into C1 minus C2 into sine of omega t. Okay. Then you write let A equals to C1 plus C2 and B is equals to I into C1 minus C2. Then you will be able to write x equals to e power minus c by 2m into t into a cos of omega t plus b sine of omega t. Okay, which can further be written as e power minus c by 2m into t into a sine of omega t plus 90 degree. That becomes again cos omega t plus b sine of omega t. So this becomes a sinusoidal function. Okay, bracket this equation. You give a number to this equation. Till now we were not giving numbers to the equation of motion of the system. Now we are giving this. Okay, so in this there are two functions now. Okay, the collocation of the two functions you have to see. Okay, for a collocation means, for example, I have f of x as x and g of x is log x. The collocation h of x is a function of function, that is f of x into g of x. So there is x log of x. So how log x is varying and how x is varying, collocatively you have to see this. Can I go ahead? Hope that is clear to everybody.
Yes, sir.
Okay. So here I have two functions. Both are different in nature. The first function e power minus c by 2m into t is we know exponentially decaying function. It is exponentially decaying function. And the next one is sinusoidal. The first one is the second one. It is a function of sinusoids. So it's called sinusoidal. So the product of these two. So here the range of this is, or this is -1 to 1. Okay. Hope that is clear. The range of the two numbers that I rounded off. And a and b are constants. Okay. So this whole function sinusoid is limited to particular values and it will be changing from one time value to another time value, whereas this one is going to exponentially decay. So the one which dominates here is 2.713, power of negative term. So as time increases, this term becomes dominating over the sinusoid. So the overall curve that you get for this is this. Draw this. Let this be the initial displacement. Okay. From here, the one which should dominate is exponentially decaying motion. Okay. So let me draw this as the dashed lines. So this function wants to exponentially decay, but multiplying this makes it oscillate. Okay. So one second. Draw this. What this system is called as? This dashed line is only the peak ones. What it is called?
Underdamped.
Very good. It is called as underdamped system. Right. the solution given by above equation is a damped sinusoid having a damped natural frequency given by omega equals to omega d, that is equal to under root of k by m minus c by 2m whole square. Bracket this, call it as equation number 7. It's called damped natural frequency, underline that word. Varsha, are you there in class? Varsha,
Yes, sir. Yes, sir.
okay. Case 3, you're right. So this time we take c by 2m equals to under root of k by m, or we can say c by 2m whole square if we take equals to k by m. Okay. What it will represent?
Real and equal root.
Very good. They both will be real, negative real and equal roots. So they will be identical roots, you can say. Right. This represents the boundary between the overdamped this system. Beside this, you write underdamped system. Write it as underdamped system. Hope you wrote that. Right. This represents the boundary between overdamped exponential motion and the damped sinusoidal motion. Full stop. This particular motion is referred to as critically damped motion. Full stop. Next line you write the roots of the characteristic equation are identical, that is the roots of the characteristic equation are identical, that is lambda 1 comma 2 is equals to, so the term inside the root will become 0 and both the roots will become identical to a value or the expression minus c by 2m. Call it as equation number 8. So when the roots are equal, what is the solution of the second order differential equation? What is the solution?
1 plus C2x e to the
C1
power
plus
lambda t.
C1
C1
plus
plus C2t
correct
and e to the power lambda t.
e power lambda. Very good. Right. X equals to C1 plus C2t, which becomes the linear equation, into e power lambda t. So the collocation is C1 plus C2t into e power, what is lambda? Minus c by 2m into T. So in this also exponential term will dominate. Bracket this. So this is a critical damping solution of the critically damped equation of motion of the critically damped system. Right. If lambda is a negative constant, comma, then e power lambda t will go to 0 faster than, because that is exponentially decaying, and C1 into T1 plus C2t is an increasing, linearly increasing function, will go to 0 faster than C2t goes to infinity as time increases. Full stop. Is there a sinusoid in this? Will you see any oscillation in this?
No, sir.
No, sir.
No,
No,
sir.
Okay, we didn't saw the oscillations in the first one as well. Okay, in the first case we didn't had the oscillations. Okay, so when you have this case, you have no oscillation. When you have the roots complex, you get sinusoidal function here, like this or like this. Okay, you will see the oscillation because of this sinusoidal part in the function. If that is not there, you won't see the oscillations. You will see motion, obviously. This is x naught, initial displacement. If you give this initial displacement, it will critically damp. So in a considerable time, it will come to the equilibrium, but it will not execute oscillation. It's called critically damped system. Draw this figure, everybody. So it will have, okay, so it will have, so what is undamped natural frequency? If there is no damper, what is the undamped natural frequency? You are doing vibrations now. What is omega n? It's called undamped natural frequency. It's not, don't get confused with the word underdamp. Underdamp means it is under damping. Okay. Undamped natural frequency means without a damper if you have K by M. Agree?
Yes, sir.
Call it as equation 9. Right. For a critically damped system,
Sets 10 equation.
written, mark it as 10. Okay. Right. For a critically damped system, the damping constant is equals to the critical damping coefficient is equals to the critical damping coefficient. So let Xi denote the damping ratio. So Xi is given by C by CCR, bracketed, call it as equation number 11. It's called damping ratio, where what is C is the damping coefficient and CCR is called as critical damped coefficient. Critically damped coefficient, you write. Critically damped coefficient. So if C equals to CCR, okay, the damping is critical. So you can write, it implies C by 2m for critical damping is equals to under root of k by m, that is omega n. So this C is CCR. So what you can write? CCR equals to 2m into under root of k by m, which can be written as 2m omega n, or you can cancel out root m, and you can write 2 under root of kn. Bracket this equation. Call it as equation number 11. Okay, call this as equation number 11. So write one note. Or you can, in note you write these points. For a critically damped system, Xi equals to 1 implies C equals to CCR. Next you write, for a system with no damping, Xi equals to 0 implies C equals to 0. And the motion is an undamped oscillation with frequency omega n equals to under root of k by m. Okay, right. From equation 1, what is our equation 1? D square x by dt square plus c by m into dx by dt plus k by m into x equals to f of t. You can write d square x by dt square plus in place of c by m, what you can write? In place of c you can write as xi into CCR divided by m, dx by dt plus k by m into x equals to f of t. So from this, what is CCR? You can write CCR as 2m omega n. Write like that. Strike out the masses from the numerator and denominator. You get d square x by dt square plus 2 xi omega n into dx by dt plus omega n square into x equals to f of t. Bracket it. Call it as equation number 12.
It will be 13 and before that 12.
Okay, fine. Call this as 12, this as 13. Okay, right. Equation 13 is referred to as the standard form of a second order differential equation with constant coefficient. The characteristic equation for the standard form can be written as lambda square plus 2 xi omega n into lambda plus omega n square equals to 0. the roots of the characteristic equation are, if this is the characteristic equation, what will be the roots? Lambda 1 comma 2 is minus c by 2m plus or minus I into under root of k by m minus c by 2m whole square. Okay. When what is c, or where you write, where c is xi into CCR, that is equal to xi into CCR is 2m omega n. Okay. So you can write, in place of c you can write that you get lambda 1 comma t equals to minus xi into 2m omega n divided by 2m plus or minus I under root of k by m is can be written as omega n square. Agree? Since omega n equals to under root of k by m, you can write omega n square as k by m minus xi into 2m omega n whole divided by 2m whole square. Cancel out the like terms. 2m you cancel out in both the terms. See what you are getting. You will be getting it as lambda 1 comma 2 equals to minus xi omega n plus or minus I into, take omega n square you have here in both the terms. So I omega n into under root of 1 minus xi square you write. Hope it is clear to everybody. Everybody got this?
Yes, sir.
Okay. Call it as equation 15, right? Should be.
Yes, sir.
No.
No, above one is 14.
Okay. Fine. It's called equation number 15.